Our planet is inhabited by millions of species of plants, animals, and microbes. The distribution of these species is uneven, and their groups exhibit various patterns. The most widely recognized pattern of biodiversity is the latitudinal gradient, in which there is an increase in the species richness from the poles towards the tropics. Except for a few areas such as the deserts, tropical regions are richer in species diversity as compared to the temperate and polar regions. For instance, Colombia, located at 4 degrees north, has almost 1,400 bird species, while India, at 28 degrees north, has approximately 1,200 bird species, while New York State, at 41 degrees north, has 105 bird species, and Greenland, at 71 degrees north, has only 56 bird species. Moreover, tropical forests have greater species diversity than the temperate forests. For example, a forest in Ecuador has 10 times more species of vascular plants than the forest in Midwest USA. Did you know that the tropical Amazon rainforest in South America has the greatest biodiversity in the world? This rainforest is home to several million species. Interestingly, biologists believe there may be at least 2 million species of insects waiting to be discovered in these rainforests. But why are the tropical regions so rich in biodiversity? Evolutionary biologists and ecologists have put forth various hypotheses. According to one of the hypotheses, evolution of species is a function of time. In the past, the temperate regions have often faced glaciations. In contrast, the tropical regions have been relatively undisturbed for millions of years. As a result, the tropical regions have had a long evolutionary time for species diversification. Another hypothesis stated that unlike temperate regions, the tropical environments are relatively more constant and predictable. Such constant environments encouraged niche specialization and led to greater species diversity. According to yet another hypothesis, the availability of abundant solar energy in the tropics contributes to higher productivity, which indirectly leads to greater diversity. Apart from latitude, the area of a place too determines the species diversity or richness. A relationship between species and area was proposed by a German naturalist and geographer, Alexander von Humboldt, while he was exploring the wild in the South American jungles. According to him, within a region, species richness increased with the increasing explored area, but only up to a limit. To analyze the relation between the two entities, species richness and area, he plotted a graph which turned out to be a rectangular hyperbola with the equation S is equal to Ca to the power Z. However, on a logarithmic scale, this relationship is linear and is given by the equation log S is equal to log C plus Z log A. From the equation, the value of Z can be derived as shown here. A higher value of Z suggests that the nature of habitat changes and becomes more accommodating, causing a proportionate number of species to spread across a wider area. In contrast, as the value of Z decreases, there is a decrease in the biodiversity of that habitat. According to ecologists, the value of Z for small areas ranges from 0.1 to 0.2, irrespective of the taxonomic group of the region. For instance, the value of Z for birds in California, mollusks in New York State, and plants in Britain are amazingly similar. However, the value of Z ranges from 0.6 to 1.2 for very large areas such as continents. Interestingly, the value of Z turned out to be 1.15 when the species-area relationship was determined for fruit-eating birds and mammals in the tropical forests of different continents. Therefore, in nature, species diversity of a region depends on its latitudinal location and its area.